All right, I think we're live now. Okay. Hello, hi everyone. Thank you for joining our workshop on this Tuesday. So today the topic is going to be on the TypeScript SDK and how to use the TypeScript SDK to basically interact with the Sui node to do like, a range of like function calls and things that you will want to do. And the person who will be presenting is going to be Icefox from the team Scallop. And yeah, Icefox, do you want to do like a quick intro of yourself?
Yeah. Hi guys, I'm Ice Fox. Currently, I'm working at Scallop Labs, and yeah, we're now building a over-collateralized lending and borrowing platform on the Sui network. Yeah, that's for me.
All right, great. Thank you. Okay, I'll give the stage to Icefox now for him to start his workshop. And then if any of the viewers have any questions, you can type the questions into the chat, and then we'll answer them at the end. All right, Icefox, thank you. You can start.
Okay, so today the topic here is that TypeScript on Sui, and it's mainly about using TypeScript to interact with the Sui blockchain. And the major application of the TypeScript on Sui network is three parts. The first one is the write state to the blockchain. That is mainly about send transaction using the TypeScript SDK. And the second part is also important is the read read on-chain data, that is read state from the blockchain. And there are two parts for reading data from the Sui network. It's the object content, and the other is that you do a dry run to get some customized queries for the on-chain data. And the third part is about the contract itself. And it's like you can use the TypeScript to just publish and upgrade your contract without using any other CLIs. Okay, so first things first, um, we're going to talk about how to use TypeScript to send transactions. And so let's get started. And since this is actually very practical skills, so I think it's better that we can learn this by doing so that you can see how it goes when you actually do the coding. So it'll be great if you can, such as if you want to follow the steps and code along. And actually, for this workshop, you only need a basic level of TypeScript just to in order to follow up the workshop, and maybe a little understanding of the Sui network, but not too much. So let's go to the code. Okay, so here is actually a overview of a very simple example of the transaction, but I think I'll delete it to guide you step by step on how to implement a basic transactions. So here, let's delete all. So the the principle is that you always keep your private key private, right? So I just put my private key in the .env environment. So I just import this environment. And before I start, I need to define a function, like to contain the main code of our demo. Yes. So first thing you need to do is actually because currently for now I've already installed the necessary TypeScript SDK. That is this one at miston/sui.js. You need to install this TypeScript SDK in order to follow the workshop. Okay, but I already installed it, so I just go to this file and start import from it. Okay, so the most important class is this one, transaction block. Yeah, it's a core of the transaction on Sui, because Sui actually has a very innovative mechanism called programmable transaction. The core is the transaction block. I'll show you how it works. So basically, you just need to make a new instance of this transaction block. Like you can do something like here we just want to do a basic transaction, that is to transfer the ownership of an object to another address. It's very, you can imagine it as something like transfer one of your NFT or one of your coin to another person. Okay, so under this transaction block, you actually have some predefined method that you can use. The one we are going to use is the transfer objects. Okay, transfer objects. So currently, this transfer object actually needs two parameters. The one is the objects, the other is the address that you want to send this object to. So I've already prepared an object ID, so I will just use that object ID to do the demo. That is this one. This is object ID that I want to send. Okay, I'll import this object ID to my code. Okay. And then let's do it for ID. I just pass it to this transfer object function. And the second thing is that I need to get the address that I want to send to. So for here, I just want to like send it to myself in order to just redemo this code. So I just want to send it to myself. So how can I get my own address? That is, you need to do another initialization for your account. Like you need to get your account. Since I've already stored my like I do some initialization here, initialization here, and then I want to like get my secret key first. I've already put my secret key under this environment variable called secret key. Okay, and then in Sui, actually, your secret key is the encryption of your secret key is like ed is like called ed25519 scheme. So you need to actually convert your private key into a address. So this is how you can do it on Sui network. Okay. So here it's like just I want to see my key pair, initialize my key pair. No, this one should be secret key. Okay, actually this secret key is like it needs a unint 8 array for this parameter, but here we actually have a string. It's like encoded in base 64 format. So here actually you need to convert your base60 format secret key into this on int8 array. So how you can do this for here, like you can use the buffer to help you do this. Yeah, but we're not done yet, because when you convert your secret key, usually it contains 33 bytes instead of the required 32 bytes. Because the first byte represents the flag, you need to remove that flag. So just like here, slice the first bytes, and leave the other 32 byte as the real key. Okay, so this is how you can initialize your key pair in the TypeScript SDK. And then here, how to get the address is that after you get your key pair, you can get your address like let me call it standard, like say key pair docs. Sender's address, right? Let me get it. Another one is that you need to initialize a signer before you can get the key pair, because usually key pair can't directly derive your address. You need to get it from the signer's instance, raw signer. It's actually called the raw signer. Okay, so what actually it does is that you can create a new instance of this raw signer, but it also accepts two parameters. One is the key pair. Just we have just created the key pair, right? So we just pass into these constructors. And the other function that we need is the other parameter that we need is provider. So what does a provider do? Is actually is kind of a network instance used to interact with the Sui full node. You can also init the RPC provider by importing this JSON RPC provider class, and then just init like this. Create a new provider, JSON RPC provider. Okay. But notice that it also accepts two parameters. One is the connection. This connection actually specifies which network you are actually interacting with. Since Sui actually currently has three kind of network. One is the devnet, the other is testnet, and the rest, and it's also the mainnet, right? So for the demo purpose, I'll just use the testnet. So I need to initialize the RPC provider with the testnet connection. You can also import this connection directly from this Mistance SDK and pass it into this provider. Done. And then pass the provider back to the signer. And then here we have get the signer. So with the signer, actually, we can get the address. This is actually your account's address corresponding this to this secret key. In order to check it, actually we can like print this and see how it looks like. And run the scripts. Okay, and let's try it. So yeah, you can see here the actual address is like this one. we can, let's see, we can check it in the Explorer and see what kind of facet it actually contains. Yeah, actually, this is a account that I created before. It contains many different kind of objects. Okay, let's go on and remove this. And let's pass it as the recipient for this object. I just transfer it to myself. Okay. And after this line, you notice that there is still a red line for this object ID parameter, because actually what this transfer object function really wants is not the string, not the string type of the object. It actually want another form is like this one. Passing something like this, and it's like object ID we have passed in. And the second parameter is that let me check it. Object ID is the ID, right? No problem. And then we get back to this one. And the second parameter is like you need to pass in like your address, just like this. Okay. tx.objects, but it's still giving me some errors. Value string, right? Object explorer. Let me check it. S still wrong. Okay, why it's wrong? Because actually this function really one is it's like a array. You can transfer multiple objects into one address at one time. So actually requires a array type like this. So for example, here I just pass in one object, but actually what you can do is if you want to transfer multiple object, you can pass in like multiple this kind of things like this. Right. Okay. And after this, actually we have defined what this transaction really want to do. Currently, we only add one action for this transaction block. But actually what you can do is that you can like keep adding more. Like after you transfer this object, you want to like do some call some contract method, or you like do other things like split coins or like merge coins. It's all okay. You can put like many different transactions into one block. Okay, for this here, I just keep it simple to transfer on one object to another. So after this, we have constructed transactions, and the next thing we want to do is that we want to send this transaction out to the blockchain to let it get confirmed. Okay, so here we are going to do some code for send out the transactions. Okay, for sending out the transactions, we're going to use these signers we have initialized. It has a capability to sign your transaction and send it to the blockchain. So under this signers instance, it contains a method called this one, sign and execute. transaction block. So what they accept is passing your transaction block like this, and then that's it. You only need this line to send out these transactions. And after this, I just want, let's run this script and actually send out this transaction. Yeah, you can see the console log. Actually, it logs the digest of the transaction you have just sent out. And the other thing is that whether or not you have to wait for local execution, for now it's forced, because in this way, this transaction response will be faster. And let's check it on the Explorer to see whether what's the transaction result really looks like. Like here, yeah. So first you can see this transaction is successfully confirmed on the blockchain. And you can see the summary here. The amount, this amount is actually the gas cost for these transactions. And the other thing is that the the changes for the object, like this is the object that I just sent out, and this is actually your Sui gas coin object. Those will be changed because the version will be updated after these transactions. And you can also get the other informations from the browsers, like the most important part is you can check your gas budget. This is how much gas you spent for this transaction, and the other info contains your like your gas price and computation fee and then storage fee. Okay, so these are the output of this transaction. So just now we have implemented a very basic transaction with this few lines. We send out the object to another address. Okay, so before I go on, actually, what I want to do is that I want to go deeper into how it really works for for the transaction on Sui network. And by illustrating this, I will show you some like code to demo the what's really happening behind the scenes. I think it's important for us to do some like optimizations for our code for our transaction performance. Yeah, since Sui actually is a very high performance blockchain, if you want to like fully leverage the potential of Sui network, it's very important to keep in mind some of the best practice if you want to like send your transaction really fast and get it confirmed. So here I want to do a benchmark and then record the, the time, like how much time it actually takes to send out the transactions. And market. Run this script again. Yeah, you can see actually from the start to the end, it takes like 3 seconds to actually get this transaction confirmed on the blockchain. But actually, I have to say, the optimal performance for Sui network is actually less than 3 seconds. It can goes down to like 1 seconds. So let me show you how actually it can be achieved. Um, First, let's build this transaction. Build this transaction. Let's make as a provider for you to build this transaction. In order to build your transaction, actually you need to set sender before you build the transaction. So here I just add 2 lines of code here. The 2 lines of code actually build the transaction and then send out the transaction. So let's first run this script to see the change. Right. Right now, you can see the real performance. It's like it goes down to 1.2 seconds. So the difference here is that I just pre-built the whole transaction before I really sign it and deliver it to the blockchain. The difference is that if you did not do this, if you didn't do this, it will actually also try to invoke this build method. If it detects that your transaction has not been built, you will invoke this build. So if you manually build this transaction, it will skip the build in this sign execute transaction block. So so why it's why I want to like say this is that because it actually you have a way to optimize your performance for sending out your transaction. So how you can actually optimize it is like you can currently, because I build your transaction with a provider means that I need to build a transaction and to interact with the full node in order to build it. Means that it also involves some network round trips for building your transaction. But actually in the Swiss mechanism, you can also build your transaction locally. It means that you won't need to actually really interact with your with the Sui network before you send out the transaction. You can imagine it like that. For example, you on Ethereum, there is a concept called nonce, right? For example, if you don't know the nonce for your current account, how you can send out the transaction? You first need to query your nonce from one of the nodes on blockchain to get the nonce and then add it by one and then send out the transaction, right? So the mechanism here is basically the same. For here, that actually, like this object ID, there is also a concept called version. When you send out the object to the blockchain, it also requires you to specify the version of your current object that you want to send out. So if you didn't specify the version, because currently the thing is that we just provide a simple object ID instead of the version for details of the object. So what is actually the full details of these objects? Like you can check it also on the browser to see there's a object ID for this object, and there are also some other informations like the version and another info is a digest of this object. So here actually, if you don't want the SDK to use extra time to parse your object D, what you can do is actually like passing the full detail of your object. And the full detail looks something like this, something like this. Yeah, there's another object, right? Yeah. So actually, this is the full detail of the object that you would like to send out. So in order to get your full details, what you really need to do is that you need to quarrel this from the full node. So I have just read a simple script, also using the TypeScript SDK to quarrel the object full detail from the full node and run it to get the latest version and the digest for my object. Okay, so you can see this is the object ID and the version and the digest of your current object. And I want, I'll paste it. I just paste it here. So I just pasting the object ID version digest for this object, and then I can pass it, replace the object ID with this object. And this time we don't build and see if I replace the previous pure ID with the full content of this object and see whether it can speed up the transaction or not. Yes, I think it's like compare it, compare it with just passing the object D by 3.7 seconds. And not so much and almost identical. So, but this is actually one kind of optimizing you can do. Let's keep going, and I'll show you another optimization that you can do to achieve some optimization for the transaction. Uh, for those of you that you might be familiar with the transaction on Ethereum, it's like for there is a concept I just checked like here. You need to like set the gas price and the gas budget for your transactions. On Sui, actually, there is also a mechanism that requires you to spend some gas for the transaction. But here, we haven't specified the how much gas we're going to spend for this transaction, right? But actually, if you don't specify the gas information for your transaction, it will automatically determine it for you. So in the background, what it does is that actually it runs a simulated transaction on the full node. Is means that it pre-run a transaction and calculate the gas cost for your transactions and set it for you. So here's what we can do is that we can set the gas informations manually. So like here there is a method for you to set the gas budget for your transactions. The gas budget for transactions is like it's getting this budget as a number or big int type. Um, so you can know this is the gas budget for the transaction we have just sent out. It's more than 3 million missed. So we can specify here like 3 million missed. On Sui, actually the decimals for Sui coin is 9. So the unit is 9. Like this is 1 Sui. So actually we just need to specify like 4 million, and that is more than 3 million. It should be enough for the gas that we need. Okay, so except for the gas budget for the transaction, you also need to specify the gas price, like how the gas price is on Ethereum. Actually, if you set the gas price higher, then your transaction will have a high priority to get executed on blockchain, right? So the mechanism basically is the same, but on Sui, here is that the gas price actually stays stable during one epoch. So we just need to check the gas price for this epoch. Here is it's the 1,000 missed and set it. So for each epoch, you need to check the gas price for that epoch and set it accordingly. So now actually we have set the gas budget, gas price. Seems like we have set all the information right, but not yet, because on Sui there is a one more thing that is need to be set for the gas. It's called the gas payment. So gas payments means that uh, it actually you have, if you have Sui in your account, usually it can be it is like multiple objects, multiple Sui objects that contain your whole Sui balance, right? So here is that you need to specify which objects you are going to use for paying the gas. So the format here is that you also need to specify some format like this. It's an array, and gas coin format is something like this. It's almost the info is the same as this object, right? And in order to get it, I also need to query the Sui under my account. Okay, you see, actually there's only one Sui object under my account, so I just copy it. And then passing to this gas payment. Yes. So, for example, if you like have several small Sui coins, you can pass in multiple coins in order to make a larger one to pay your fees. But here I just need one. And then after setting all the informations, but we still keep using the raw IDs instead of this four form, and by just optimizing the gas and see whether it can speed up our transactions. Yeah, 3 seconds, right? Let's run it because the network maybe have some like volatile. Okay, it goes wrong. Why it goes wrong actually is that I still use this information as the gas, right? But it will give you error. The reason is that the version for this gas coin has changed. If you still use this version, then it will give out the error. So what you need to do is actually you need to update this information. Yeah, 3 seconds, still 3 seconds, no problem. And let's combine those two optimizations and see whether by adding these two optimizations, the performance, how is the performance improved compared to do nothing? Like here, I use a full form of this and also set the gas. But before I go on, I need to update the version for the object that I'm going to use. Like the gas, you see the gas version increased by 1. And then also you need to update the object. Okay, now we have set both the object's content and the gas info, and we rerun the transaction to see how it can improve our performance. Right, 2 seconds. So the improvement actually is kind of like significant if you think of it. You are maybe 1 or 2 seconds faster than normally you do without optimizations. So in order to see that difference, I might want to rerun this transaction without optimizations and then go to the next step. Right here, I just do no optimizations. 3.2 seconds. Run again. I think you should always stay above like 3 seconds to 4 seconds compared to if you do the optimizations, you can go down to 2 or 1 seconds. Okay, so actually, these are after these are illustrations, you can know that what it really happens under the hood is that I have a slice for summary. All the things is that actually, if you don't specify your object version and digest, the SDK will just fetch it for you by requesting from the full node. So it means that it requires some network requests and takes some time. And the other part is that if you don't specify your gas settings, like the gas budget, gas price, and payment, and then under the hood, you will do a dry run, meaning that it will simulate the transaction on the full node and estimate the gas budget for you. And also requires you to send out the transaction byte to the full node in order to execute on remote and fetch it for you and transfer it back. So here, actually, you need several network round trips if you just use the like no optimizations. So the thing is that the potential optimization here for your transaction is that you keep track of your objects locally, meaning that, for example, if you are building a wallet or if you are building an app that you want the users to send out the transaction as quickly as possible, you need to keep track of the user's objects version locally. So the next time you want to send out the transaction on the user's behalf, you just retrieve it from your local storage, like, and without requesting from the full node. So it will be faster. And the second thing is that for the gas budget and price, it's a bit trickier because every transactions are on different contract may take more or less gas budget. So the thing is that if like in advance how much a certain operations for a contract will cost, you just preset it for you. For example, some well-known DEX or some well-known protocols, those price budget are relatively stable. So you just set it for the user without requesting the full nodes. It will also save the users a large amount of time to send out the transactions. So these are the two areas optimization for the users in terms of the transaction performance. Okay, so let's go to the other part is that except for sending out the transactions, actually you want to also read the transaction, right? Or read the data. Currently, I have just shown a very simple way to get the like object content from the full node. It's very simple. You just initialize this JSON RPC provider and specify the network type. Here is a test network, and then your object ID to get or the detail for object. And also, there's a there are other methods under these providers. Like you can get, I think there is a call like you can multi get objects. For example, sometimes you might need to get multi objects, so you can do it like this: get multiple objects by doing one network request. Yeah, so this is how you can corral the objects on the blockchain. And the other way to know that's the to corral the data from the blockchain is like this one. Here's that it also leveraged the provider, but the different part is that we use this dev inspect transaction block. So what it actually does is that it runs this transaction on the full node and returns the result to you. But this is gasless. It means that it runs. It's not get confirmed on the blockchain, but it just simulate the core. It's used for example, you want to corral some customizations for your search. Like here, I just corral this very simple thing called counter. This is pretty straightforward. So for example, here I have a counter. It contains a value. And here I just want to know the value of this counter. How I do this? One way is just I correlate the object and get the field. But another way is like you can have a method like check value. It returns the counter's value. And then here I call this method like counter check value and then pass in this counter object, and later it will actually return results. And this results contains that U64 value. And with this, you just decode it with the BCS tools, and by specify this type of this value, and you can actually get like the real value of the counter. It's not that useful in this example, but it's extremely useful if you want to correlate like multiple aggregator informations and you do it in a contract, and then you get one single aggregator results, which will dramatically save your time if you compare to you with correlating multiple object and do the calculations, and that will be useful. And the other part is that it's useful for correlating like dynamic fields, because under dynamic fields, you also need to, it's very complex just by correlating the object. And in this case, you can do customizations on the contract and do the query. Yeah, so this is the two ways. These are the two ways you can get the data from the Sui blockchain. So here's a for reading object. You use the provided the get objects, and there's this get multi objects. And for customized query, you can use the dev inspect transaction block. Oh, okay. The last thing that I want to show the demo here is that sometimes I think it's for especially for like front-end developers or some purely TypeScript developers who don't want to mess up with other tools like the CLI or Rust. I have like introduced a tool that is very straightforward to use to publish your Sui contract just using TypeScript. So like here, let's also take this counter contract as an example, and then I'll show you a way what you can do it like this. Publish package. Publish this counter package. Okay. So like here, I've made a tool called SuiKit, and another tool called package publisher. So these are the tools actually a simpler but more powerful version of the Sui's official SDKs. Like here, this is how you can publish a package and by 3 lines of code here. Like here, you just need to specify the path. The path of your package is here, the counter, and the other thing is that you just pass in the package path and the signer that you want to use for this publication of the contract. So let's see how it works in action and run this script. So yeah, just now I have published this module, counter module to the testnet Sui blockchain. And in the console, you will log out your informations like your package IDs and your upgrade cap IDs. So compared to the CLI version of how you can publish a package, it's actually much simpler, and you can integrate this with in your TypeScript tools. Okay, I think that's for it today for demoing some simple applications of for TypeScript on the Sui network. And it's about me. I'm actually tech lead at Scallop and move from Dell members. Currently, I'm also maintaining some open source softwares like SuiKit just mentioned and the Sui package kit and some plugins for using how to make it simpler to use TypeScript on Sui network. And these are my contact informations. Okay. Okay. Thank you. Thank you.
Great, thank you, Icebox. That was a great workshop and super useful for teams who are going to be building projects for our hackathon. Just really quick, if you're watching this and if you haven't signed up for the hackathon yet, you can do so at hack.sui.io. So we're still open, and the hackathon will run for about 1 more month. So you're still free to like join. And also for the last one, let's see if there were any questions from our chat. I see one question at the end from Vita Bread. So I think Vita Bread wanted to ask question, when should we use TypeScript and when should we use move?
When should we use TypeScript and when should we use what other language?
Yeah. Yeah, I
What's
think
the
like this is I think Vita Bread is fairly new to Sui. So I can answer this one. Basically, move is the language you use for writing smart contracts on Sui, while
okay?
TypeScript is the language you use for interacting with the Sui SDK. So yeah, I saw. Do you want to talk like a little bit about like when do you want to use the SDK?
Yeah, actually, this TypeScript SDK for the Sui network is very powerful, you know, because there is a core concept in Sui Move. It's called the programmable transaction. I think it's the most innovative part for the Sui blockchain because actually what it actually allows you to do is like you can call like contract protocol A, like you can on a DEX, right? You swap from USDT to USD or BTC, right? And then when you get the BTC, you can use that BTC to interact with another DEX, like DEX B, and swap BTC to USDT. So what it really does is that if these two DEX have some like arbitrary opportunity, you can do some make some money here, right? But usually on Ethereum, what you can do is actually publish a new contract, right? And you call this two DEX method and do the arbitrary on your contract, and then you use your whatever whatever tools to interact with that contract. But in Sui, this is totally different. You don't need to like writing a new or publish a new module to the Sui blockchain. What you need to do is actually just use the TypeScript SDK and call the like DEX-A and get the BTC and also call the DEX-B and swap the BTC back to your coin and then make profit and transfer the profit to yourself. All those things can be done in totally in TypeScript. You don't need to write any move code in order to like call multiple protocols, right? I think that's the beauty of the programmable transactions. Yeah, and it's a powerful of this TypeScript SDK.
Okay, cool. Yeah, I think that is a great answer. Yeah. So, like Isoc mentioned, some of the most powerful features of Sway is best access by using, the TypeScript
Yeah, true.
SDK.
This is fully supported, and
Yeah,
actually, it's easy to use. Just like I just mentioned with the simple transaction here, it now looks like a little complex, but what's simple form is just like here. It's just like this one, right?
great.
Very pretty straightforward. You can only need a few lines to call multiple. Maybe you just need to add another line to call several protocols in one transaction without publishing new contract.
Great.
Yeah, something like that.
Yeah, and the topic that Icebox is talking about right now, like basically programmable transactions, we will have a workshop next week just on that. So make sure that you also tune in for that. All right, so I
Yeah.
think our time is up, and yeah, thank you for our viewers, and also thank you for Icebox from Scallop for giving this great workshop.
Okay. Thank you. Thank you for listening.
All right, I will see you guys next time. Bye bye.
Bye.